Hello, my name is Dirk Cobry. Today I'm going to show you some tips and tricks for using MPI on the High Performance Computing Center. MPI stands for the Message Passing Interface. It is a programming library used to let programs communicate with each other across nodes on our cluster. The first thing we need to do is log onto the HPC, go to a dev node, and download an example. I've already logged onto Gateway and SSH to dev Intel 09, and the first thing I want to do is module load power tools. I've talked about power tools in a couple of my other videos, but the power tool I wanted to use today is called get example. And if I just type get example without any arguments, it will list all the examples that the HPCC staff has put together to help you use the system. The example we're going to use today is called Hello MPI. It downloads that example into your current directory, so all we have to do is cd now to Hello MPI, and we can list that directory and see the files that are available there. Let's have a look at the Hello MPI program to see what it looks like. This is a very simple Hello MPI program. It actually doesn't care how many nodes it runs on. The first node will have a rank of 0, and it will just print that it is the receiving processor, and then every other node that the job runs on will have a different rank other than 0, and it will run this part of the code, which just sleeps and then sends a message back to the master node, and then once it's done, it just returns. Let's compile on the command line just to see how it works. And if we compiled correctly, I should be able to list, and the Hello OpenMPI program is right there. What does that look like if we want to run this program? We can type /hello GNU mpi.e. Since it's only running on the current dev node, I only get one processor. However, I can actually make it run on more than one node, and what I need to do is create a host file. And the host file has to list all the nodes that the program will be running on. I'm just going to run 4 copies on the dev Intel 09, so I need to create a host file with dev Intel 09 listed 4 times. And an easy way to do that is just to echo that into a file. And then I will append. That's now written twice, 3 times, and 4 times. And if I cat the host file, there's the file I want to create. Now I can use a command called Mpi Run. I have to give it the number of processors, which is, in our case, is 4. I have to give it the host file name. And I have to give it the program name. Now when I run the program, I can see all 4 processors, and since there are sleeps in the program, they just all go in order. The dev node is designed just for testing, so I can test these programs running on the dev node, but they won't actually run for very long. We have a 2-hour limit on the dev nodes. To get the power out of the cluster, you want to submit the job to the batch system. To do that, you need a batch script. So let's make a very simple batch script. I'm going to use a little hack to make the batch script called cat. It's a very poor man's editor. We're going to call it test.qsub. The very first line has to be your shell. The next line, I'm just going to join the output and error, which I always do. And then I have to tell how many resources I want. I'm going to use -l wall time equals 1 minute We don't need much memory, but I'm going to give it 2 gigabytes anyways. And we're going to need nodes equals 10, ppn equals 1. For MPI jobs, you almost always want to increase the number of nodes while keeping your processors per node equal to 1. You can go up to 144 nodes in any one job. I think that looks fine. First thing you need to do in all scripts is cd to the directory where your program or data is in. An easy way to do that is to type cd pbs original working directory. And then we have to run that Mpi Run command again. But in this case, since we're running it from a submission script, the submission script knows how many nodes it has and actually creates a host file for MPI. So we don't have to include any of that. All we have to do is include our program name, which in our case is hello gnu openmpi.e. I like to finish most of my scripts with the qscat command that will list all the resources that I used, and that is a submission script for running an OpenMPI job. So to exit the cat as an editor, just add a couple extra lines and hit Control-C, and that file now is called test.qsub. So I'll cat it again without the piping, and there's the submission script that I wanted to create. Now I just qsub that submission script, and it gives me a job ID number. I can use that job ID number to monitor the job. I'm going to use the qstat command and my username and be able to list my current jobs that are running. This is already running. You can see that by the R state. And my guess, since this program is very fast, if I do a list, I will see the output for my test program, which I do see. Test.qsub, and then there's the job ID. So now if I cat that file, I can see what would have printed to the screen. So you see the first thing is it runs the program. So I ran it on 10 nodes, so I see I'm the receiving processor, 1 of 10, and then the rest of the nodes printed out their message. And then after it finished running, it printed out our stats, which can be helpful if there's a problem. MPI is a standard used to pass messages between nodes. There are actually many libraries that have implement that standard. By default on our system, we use the OpenMPI standard. We also have something called mvapage. If you would like to use mvapage, you can just use the module command to switch between the two modules. Module unload, OpenMPI will unload MPI from your current module. Then you can do module load mvapage. So let's just do that as an example. So if I do a module list, I can see my current modules, and you can see that my default OpenMPI is number 2 on my list. Now I can do module unload OpenMPI. And then when I list my modules, I don't have OpenMPI anymore, and I can do module load mvapage. And now I've got mvapage loaded. Generally speaking, OpenMPI and mvapage are the same. There aren't many differences between them. However, when you write a submission script, you need to make sure that you include the module swap of the OpenMPI and the mvapage inside your script. And instead of using Mpi Run like you would in the OpenMPI script, use Mpi exec in the mvapage script. Other than that, everything should be the same. So today I've shown you how to use OpenMPI to compile and run your code on the High Performance Computing Center.